Welcome, everyone. Good morning or good evening or good afternoon from wherever you happen to be joining us from. My name is Melissa Russell, and I'll be your host for today's webinar, End-to-End Application and API Security. Before we get started with introducing our speakers, I did want to let you know we will be recording this session, and we will have a Q&A section at the end of the presentation. Please feel free to enter your questions in during the presentation. A couple of them we might be able to just answer on the fly. If you happen to be joining us from LinkedIn, if you have any questions, go ahead and put them in the comments field. I'll make sure that we get those addressed at the end as well. I'd like to introduce today's speakers today. I'm joined today by Alex Diaz, who is our VP of Security Solutions, and Rick Kruger, who is our Regional Director of Sales, both joining you from beautiful California. At this point, I'd like to go ahead and let you guys get started. Take it away.
Thanks, Melissa. Really appreciate it. So, good to meet you all. And let me just, sorry, I have to reload this. For some reason, it's not allowing me to advance to the next slide. This should just take a second, and hopefully I can get the next slide now. Yes, excellent. Great. So this is, I guess, the requisite customer slide that all vendors and solutions providers normally provide some view into. So Wallarm, if you're not familiar, we have a little bit more than 200 customers around the world. Some of the sort of Fortune 500 customers, you can kind of see them here: Panasonic, Victoria's Secret. There are also some other customers that are kind of represented on this slide that I'd like to highlight. If you haven't heard of Miro, Miro has become very, very popular as a collaboration platform, particularly since really the beginning of the pandemic. Another customer you may or may not have heard of is Rappi. And I'd like to just call both of these customers out because they're protecting billions, literally billions of API requests per month with the Wallarm platform. So that gives you a little bit of an idea of the scale of the platform. Also, G2 has rated Wallarm as the #1 API security solutions based on customer reviews. You can also see the stats here regarding the number of billions of API requests we're protecting and the number of apps and APIs. So moving to the next slide. And this is just not moving forward for me, and I don't know why. This is rather frustrating. Okay, excellent. Yeah, I apologize. For some reason, I'm losing control of my mouse. And so unfortunately, guys, I'm going to have to be in this mode here because for some reason, I'm just not able to advance from slide to slide. Let me just go to the slide this way, Alex, unless you have some suggestions for me. All right. So we find ourselves in today's world where organizations are transforming themselves from a digital transformation perspective and being really confronted with a very new and more capable software stack. And that new software stack is defined in a number of different ways. So for example, a lot of organizations are moving into service meshes. They're definitely adopting Kubernetes as a deployment architecture. And we also see lots of new architectures, API architectures, and API protocols like GraphQL and gRPC. Also, there's definitely a need. There's going to be, for certain, a need to support things even like SOAP and WebSockets going forward. I would imagine that most of the folks who are attending today's presentation are using mostly REST, but we feel like it's very important if you're going to invest in a platform like Wallarm that it be properly future-proofed to be able to support this new software stack. So you may also be aware that an organization called Akamai conducted a study back in 2020. And what it found is that web traffic is predominantly API calls today. More than 80% of web traffic are actually API calls. And so this is, in a sense, a real reason for Wallarm's existence, because our platform is purpose-built to protect against malicious attacks against APIs. Moving to the next slide, you may also be aware of this, OWASP API Security Top 10. So this was introduced by OWASP a couple of years ago as a follow-on and an add-on to the OWASP Security Top 10, specifically surrounding APIs. And this is, I think, strongly indicative of the importance of APIs and the fact that API traffic is very different from web traffic, and it needs to be protected against, or attacks against APIs need to be protected against in a very different way. It's also worth thinking about the OWASP API Security Top 10 in really three different categories. So we've broken out these two in blue, and those are focused more on authorization, API authorization, and then there's also authentication. And what we find is that most organizations are addressing these three, API 1, API 2, and API 5, with things like API gateways, identity access management systems, and other authentication authorization systems. So Wallarm is in particular focused very much on the threat protection or threat prevention side. So those that are highlighted in orange here. I like to show this slide because it's indicative of the degree of innovation that Wallarm has brought to the table regarding API security and API threat protection. Way back in 2016, we incorporated into the platform something called Deep API Request Inspection. And Alex is going to talk in more detail about the API Request Inspection. If we move forward to 2019, we see that we have support for serverless architectures, integration into API gateways. Also in 2020, we introduced support for GraphQL APIs, gRPC APIs. And then if we look at 2021, we have also introduced into the platform something called API Discovery, and we're going to talk in more detail about that as well. So moving to the next slide, this provides a view into the two major aspects of the platform, and those being the Wallarm nodes. The Wallarm nodes really sit in the line of traffic, filtering out malicious API requests. The other part of the platform that's very important is what's called the Wallarm Cloud Engine, and that's delivered in a SaaS capacity. There's also communication, and it's a little bit hard to see in this slide, but what gets shared into the Wallarm Cloud is metadata that's being extracted from the nodes that gets shared up into the Wallarm Cloud for rules, refinement, and tuning. Let me move to the next slide and provide a little bit larger view of the deployment architectures that are available. So one of the, I think, our key differentiators is the ability, our flexibility as it relates to the different environments and infrastructures that Wallarm can be deployed into. So if yours is more of a Kubernetes environment, we have support for a Kubernetes Ingress controller. If you have things like Nginx, we actually function as an Nginx module. We also, as I mentioned, have integration into various API gateways. And one of the very strong aspects of the platform is that we can be deployed into a multi-cloud environment. So many organizations have support for AWS, GCP, Azure, Alibaba, and others. And Wallarm can be deployed into absolutely all of these. And so it provides an enormous amount of flexibility from that standpoint. And I also mentioned that we can be deployed into a serverless architecture. So let's take a look at the three main pillars that underpin the platform. They are discovery, protect, and respond. So the discovery relates to our ability to discover all of your APIs. And the way we're doing that is actually from the traffic. So you don't have to provide an API schema. We're going to identify and detect all the different API endpoints and expose those to you. And also the different domains and subdomains. So discovery also includes, and I think Alex is going to demonstrate this to you. So we have the ability to, from a network point of view, expose and provide visibility into domains, subdomains, IPs, and services. Now, on the protection side, and this is where I think the rubber really meets the road, and the protection is really the beating heart of the platform. So our protection is, first of all, our detection mechanisms are non-signature based. And so one of the most important things that provides in terms of value is that we're going to be able to detect zero-day attacks. So you don't have to go about writing all sorts of rules. In fact, we are going to create and configure and tune the rules automatically from the traffic. We don't require you to provide any API specs. And we also provide for protection against API abuse. And we've already talked about the OWASP API Security Top 10. Bot management is actually in development now. We expect to have that in the very near term. Now, on the response side, it's also really important to understand that any type of API security threat protection solution necessarily exists within an infrastructure and an ecosystem. So you have things like Splunk, PagerDuty, Slack. And so we provide integration into those so that we can provide a full picture and a full set of tools to act when attacks are identified. We're going to provide full visibility. Let me move to the next slide and provide just a little more insight into the response part. So we're going to provide full visibility into all the API attacks, allow you to drill down into the malicious requests and track those requests and the attacker's actions. We're going to surface the most urgent issues and to be able to automate something called active threat verification. So there are a number of detection mechanisms that are built into the platform. And Alex is going to talk about something called active threat verification. It's very important to be able to really determine what is actually a malicious request and what is not. One of the key differentiators of Wallarm is that we're able to, in real time, block malicious requests with extremely few false positives and false negatives. And so because of that, Wallarm, 90% of Wallarm customers actually run the Wallarm platform in blocking mode. And this is by contrast to most of the more traditional WAFs that are hardly ever put into blocking mode because they generate so much in the way of false positives. So one of the values of the Wallarm platform is that we're going to dramatically reduce the administrative effort to detect and protect against malicious API requests. And so with that, I'd like to turn the next part of the presentation over to Alex. So over to you, sir.
Perfect. Thank you, Rick. Great, good stuff. Can you let me share my screen? If you can stop sharing. Okay, cool. Thank you. So in the next subject, let's go over a couple more slides about the concepts, and then we move into the demo. A couple of things I'd like to touch on based on this. So let me know when you can see my screen. Are you able to see my screen?
Yep.
Okay, perfect. Let's talk about the API deep inspection. So as Rick mentioned, the way it works is for every request coming into the system, Wallarm will act as a proxy, inspecting all the requests. And that inspection will happen at all levels of the request, from a URI header and body of the request. We'll also be able to parse the protocol being used. If it's gRPC, WebSockets, GraphQL, you'll be able to understand the protocol and also the structure that is being sent using that protocol. Could be a JSON format, could be a SOAP format. Be able to identify the fields and be able to see if any field being used could be an attack vector. When you think about an attack, all these attacks could be embedded in any of those elements of the request. What Wallarm is going to do is go and inspect all the fields and elements to be able to identify for a potential attack. Even if that field is encoded in B64, MD5 sum is going to be decoded on the fly and be able to identify as an attack. The other concept I'd like to share with you is the way the rule set work and the protection with Wallarm. As you can see on the left, you have the user requests. You have the Wallarm nodes that Rick just described, where they can be installed pretty much anywhere. That could be a Kubernetes ingress controller, could be an NGINX instance, could be an EC2 instance, could be a cloud provider, could be an on-prem deployment. The deployment is pretty flexible, could be installed pretty much anywhere. So any user request is going through those Wallarm nodes, again, acting as a proxy. And then as you can see, it could be, after that is going to reach to your APIs or web services. For every request, there's a preliminary analysis that will happen at the Wallarm node, and what is going to happen is going to be a decision take from that point, and that information, metadata about the attack, is going to be sent to the backend. In the backend, there's going to be algorithm, statistical methods, sampling over 300 samples, also a component of ML, machine learning, that is going to be creating dynamically a rule set specific for that application. At that point, the backend is going to push back to the Wallarm node that rule set. The process continues. The more requests, the more traffic the Wallarm node will receive, the smarter the system is going to get, and it will enter this feedback loop, which keeps improving as the traffic and the attacks are incoming into the Wallarm nodes. This will be specific per application, and it lasts usually a period of 7 days. And this filtering mode, so like I said before, is 7 days while the system will compile this rule set that will keep moving and progressing and improving over time. Then you start in monitor mode. During the monitor mode, you assess the system. If they are false positive, you're able to adjust it by training the system. And then at that point, after 7 days, you're ready to go into say blocking and blocking. The difference between the two is in blocking mode. If Rick and I, we are behind the same IP, and Rick is sending the malicious request, and those requests made it to the blacklist, Rick and I are going to get blocked, even if myself, I didn't do anything wrong. Safe blocking acts a bit different. So if Rick is sending a malicious request and I'm just consuming the services in a normal way, only Rick is going to get blocked. Safe blocking works at the payload level, at the session level, based on the malicious payload. I'd like to talk a little bit about performance and the node architecture. Wallarm put a lot of effort on performance and also on the architecture to reduce the latency no more than 1 millisecond with the right sizing. You can see the end user on the left, top left, accessing the protected application. There is an in-memory database where NGINX will send the request for analysis, where the post analytics is going to happen. Is going to be the initial analysis that will define if that metadata of the tag will be sent to the backend for compilation and analysis to be resent back to the node. As you can see here, something important to understand is this is an asynchronous operation. So it doesn't affect the processing of the request because it's in-memory process on the side. Well, if there's nothing wrong with the application, the request will go straight to your application. Again, this is how it will look if you're going and making part of a CI/CD pipeline. You are in dev, staging, and production. I recommend running in monitoring mode all your environments. There's nothing being blocked, but allows you to assess the behavior of the system, understand the attacks incoming into your applications, your APIs, and at that point, after you are satisfied with the near zero false positive, you can have the option to move into say blocking and blocking. Perfect. So we're really excited to win a new feature that called API Discovery that Rick is going to cover a piece of the demo, and then I'll take over to continue the demo of the console. So Rick, back to you.
All right. Thanks, Alex. Okay, so I apologize again that I'm not able to go into full presentation mode here. I'm not sure what happens, but for some reason I lose control of my keyboard and my mouse when I'm doing that. But so let's take a little bit closer look at the API discovery. API discovery really helps to answer the question of, or the problem of, it's very difficult to protect against what we don't know. And so API discovery is going to provide a lot of insight and a lot of information as to what APIs you have out there, the endpoints that you've got running, the methods, and the various parameters of each, which of those parameters are optional or required. It's going to allow you to identify shadow API endpoints. And again, it's doing this based on the traffic analysis. And so what's really powerful about that is that you might have, you probably have API documentation, maybe like Swagger documentation or Open API specification documentation that you're using to define and design your APIs. And so what API discovery is going to reveal to you is what's actually running in production so that you can properly compare and ensure compliance between what's in prod and what's otherwise in staging. So let me switch over to the platform itself, the product itself, and you can get a view into this. Just reload this. Okay, so API discovery has discovered 2 domains. This one that's wallarm.com has 21 endpoints. This one has, I think it's 15 endpoints. And so right from within the interface, this refreshes, we can drill into any of these methods that correspond to the various endpoints. And now we're able to get a view into all of the various parameters. The ones that are marked with an asterisk are required. Now, the other thing that is kind of cool, if I can use that word, is the fact that you could write a rule right from within this interface. And Alex is going to provide you a bit more view into rules writing and the power of rules. Now, let's understand that the rules within the Wallarm platform are automatically created and configured, but from time to time, you might want to create a custom rule. So here, the interface provides the ability to write a rule on that particular endpoint. And here are the various conditions that are presented that directly correspond to that endpoint. We could identify what particular method we would choose. In this case, I believe it's a post. And now we can specify what we would do. So we might, for example, ignore certain attack types. And so we're presented with a number of different attack types. Let's say we want to ignore SQL injection. And then you can identify in which part of the request. So hopefully that makes some sense. Now, the other thing that's powerful about the Wallarm API discovery is that, let me just refresh this. Right from within this interface, we can also download, I mentioned you could download the OAS, or also known as a Swagger file. Let's go ahead and do that. And now I'm going to go into my Swagger editor here and just import that file that we just downloaded. Okay. Okay, so you can see what has happened here is that, again, because we're sitting in the line of traffic as a reverse proxy. We're able to uncover the structure of the API and the API endpoints. And so that's actually what's being represented in this design definition file in the Open API specification. So with that, I'm going to turn it back over to you, Alex. Back over to you.
Perfect. Thank you, Rick. Let me start sharing my screen. Let me say one more thing about API discovery. So how this is built, and I want to make sure we send this message to you guys. This is discovered via just normal and natural traffic. There wasn't any need for us to upload a schema or do any manual operation. This actually represents the real traffic going to your APIs, the real usage and how people are consuming your APIs. So directly, because you are seeing the line of traffic, this is important to understand what actually real APIs are being used, which are the endpoints being consumed by the end users. And once you have that information, you can compare to the static file you're releasing and compare is this endpoint deprecated? Is this API a shadow API that shouldn't be there? This again represents real traffic. Perfect. So let's go into some of the features that will allow you to protect your endpoints and your web services and APIs. One of the features of Wallarm is the scanner feature. Allows you to discover all the endpoints the same way the attacker is going to discover everything that's available out there, and that could become an attack vector. Using DNS technology and everything available in the DNS records, be able to identify domains and subdomains, identify the IP addresses, and port where these endpoints are running services. With this information, you can actually see that the other three aspects of the security mechanism used by Wallarm. One of them is you will see it defined as a vulnerability scanner. Vulnerability scanner is going to run a database of CVEs and CWs against those endpoints that have been discovered. It can discover application-specific endpoints or issues for example, a library, OpenSSH library has a CVE that has been released that needs to be updated or fixed, with examples of the request and response, how to exploit that specific vulnerability. And you will see it as a vulnerability scanner. The other one that Rick mentioned during his presentation is active threat verification. And you can see here has been detected a log4j attack. And you can see how this is being detected. Let me talk a little bit more about that one. So if I go to docs.wallarm.com and I go into active threat verification, you will see how this actually works. So from the initial attacks, let's say you have someone attacking your website, Wallarm will take the initial request. So you see the base domain, you see the token being used, and the attack in this case is a SQL injection, could be anything of the OWASP top 10 API or web. So it's been identified an attack. This is again coming from a real attacker. What Wallarm is going to do that is going to take the same base URI and add variations of the attack, enhance the attack by adding variation to test for vulnerabilities in your application or your APIs. In this case, I have here in my demo, I'll be able to identify and confirm that it's a vulnerability related to log4j. The last piece of technology we use in this specific section is passive detection. In passive detection, we're listening to all the responses back from your application and what you're sending back to the end user. You don't want to, of course, sending password databases or user information back to the user. That should be stopped and should make it available to the end user. The other example could be SQL errors that could be exposing your database structure back to the user. So that's something that Wallarm is going to be using. Now, going back to the deep inspection piece, where Wallarm is analyzing every single attack coming into the system, you will see this as the result of all the attacks going to your APIs or going to your specific web services. Yeah, we are analyzing SQL injection, cross-site scripting, and all these lists of attacks that could be embedded in any element of the requests. Could be, in this particular example, could be Wallarm is looking into URI header. It shows also the payload that triggered that attack, the source IP, and the error code being sent. I take another example here. I look, for example, something that has been blocked. When you're in blocking mode, you're protecting the application. This will never make it to your application. Is stopped with Wallarm. So if I go and select a remote code execution, you can see here all the elements of the request are being inspected. So you see the payload that triggered this attack, the source IP, the error code 403 was protected by Wallarm. Your application never saw this request. You can see the analysis on the URI, analysis on the header, and where the attack was found was in the body of the request. So for this, is every single request is being analyzed, and you can see the events triggered by those attacks going into your APIs and web services. Something I like to talk about triggers. Triggers is important because it's once we have the security information, what can you do with it to trigger a different action? So let's say you have an API that is used for authentication, or you want to, in a way, to rate limit the number of connections going to that specific API. So you can do, for example, login domain.com. This is my path where people are trying to log in. So what you can do is add a reaction, mark it a brute force. If someone is trying to access that specific endpoint for more than 30 requests in the last 30 seconds, you can actually add it into the blacklist and blacklist this IP for the last 5 minutes, 1 hour, etc. These are the options right here. The other thing you can do is, if you have a excessive number of attacks because you're releasing a new product and you want to be notified with it, so you can actually say, if I have 10,000 attacks per day, as a notification, you can send it to Slack, PagerDuty. You can send it to a SIEM like Splunk, Elasticsearch. We don't have the integration. You can always use webhook to make that integration happen. One of the last pieces I want to cover in this console demo is the rule sets. Rule sets are important. This is something that Rick covered quick in getting data from the API and applying the rule and auto-populating the rule based on that. The idea of Wallarm is for this rule set to be low maintenance. We want the system to take care of the rule sets. We are, the idea of this is avoid, like in old WAF or API security, where you have static rule sets that need to be created and versioning. This is not the way it works. These rules are created automatically, like I explained, during the rule set feedback loop process. So in the best case scenario, the security is going to be taken care by Wallarm, and the rules and maintenance will be minimal. So one of the exceptions to the rule is, let's say you're in blocking mode and you onboard a new application, let's say in staging, that has no concept and hasn't gone through the learning period. And then you have your new app you're releasing, and you want to put it into filtering mode for while you learn the application profile. You can put it into monitor mode. That will be an exception of the rule. Or you have specific fields you want to mask, mask sensitive data, for example. So you can select, for example, the post request. These rules are pretty flexible, and you can go all the way from a gRPC code. You can go to the JSON doc, for example, and go on specific hash, for example, social security number. In this case, any field with social security number won't make it to the backend. That's a way to comply with some of the requirements for certain companies. One of the things, in terms of visibility, we have the dashboard, the main dashboard that security engineers will look at. So you have the blue line that represents the incoming traffic, good and bad. The orange line represents requests, bad requests, where malicious payloads were discovered. And in red, the incidents that weren't verified by the system as an attack. and could be harmful or impactful to your application. Here you can define your top targets or your applications based on IDs. You can set up your dev environment, production environment, or in my case, specific APIs, GraphQL, REST, and SOAP APIs. You can see the trends, you can see the top attacks going to those services, RC on top. In this particular case, you can see also the source, country of origin, and also the data center where they're coming from. Perfect. So I think this covers pretty much the demo of the console. I was wondering, doing a quick poll to see if you want to see some live attacks and see how a Wallarm can stop them. So this question goes live. Do you want to see some live attacks? So
yes, please. There is definitely a request for one.
Okay, perfect. That's good enough then. So let me reshare my screen here and I'm going to share my terminal. So what I want to do here is I want to attack a REST API endpoint. In this specific attack, I'm going to try to send, I want to exchange my currency from pounds to US dollars. I want to send the funds to a different account. And I'm going to try to override the account with a SQL injection. So I'm going to start sharing right now so you can see it. So perfect. So let's go here. Can you all see my screen?
Yes, we can.
Perfect. So let me run this demo. Again, this is a Forex exchange API that using curl, something you can replicate yourself. I'm using a curl command. I'm using a couple of parameters here, the private keys and certificates to be able to log into that specific API. Also basic header authentication. As you can see here, the host and the target of the API. This is a request. So I'm asking to exchange $1,000 in pounds. There is nothing wrong with this request. Everything went through. It's the equivalent is 788 pounds. The tricky part here is the account number, which is defined by bin number. So that's the account. Once you do the conversion where that, the funds are going. So let's try a SQL injection to do a couple of things to try to override that bank account. So I'm doing a unit select in that specific field. So you don't have any syntax validation. Your application is going to read it. And if this query goes straight into a SQL database, he's going to find it. Here on top of that, I'm actually encrypting this in a base64 encoding. So I'm trying to hide this attack there. And even if it's encoding in base64, you can see Wallarm here has stopped the attack and declined it with a 403 error. Now let's go back to the UI to see how this looks from Wallarm perspective. You see just a brand new event attack now that just pushed into the system. The SQL injection. Again, Wallarm is inspecting all the elements of the request, showing the payload where the attack, that triggered the attack. The source IP was coming from. The error code means that's being protected and blocked. You can see inspecting the URI header, and even if the attack by base64 encoded was decoded by Wallarm, and you see it here in plain text that the attack was stopped successfully. Let's try one more. Let's try a GraphQL attack. In this example, so I have a user database. I have all my user databases. And what I want to do is try to send an email. I want to get the ID of that specific user. And that's in the normal case. What I'm trying to get after that is, as you can see here, okay, this is Alex at test.com. The user ID is 4. Now, what I'm going to try to do, the first thing is I'm going to try to just dump the database of all the users. I want all the users' IDs. So this is the first try I want to do. So I do or another SQL injection and a GraphQL endpoint. You can see here just a GraphQL query, and I'm injecting that into the email field. Again, we don't have syntax validation, and you are actually at the end of the request. This will end up in a SQL database. You will see how this is going to probably release all the user accounts because it's just dumping all the database. In this case, you can see actually has been stopped by Wallarm. And now we can see here, if I go to the UI, you can see the second attack I just created, how that's being protected by Wallarm. So now, again, this is a GraphQL protocol. You can see the payload that triggered the attack, full GraphQL query, how the attack was embedded within that GraphQL query, and all the elements inspected, protected by the platform, by Wallarm. Your application never saw this request. Let's do one more. Let's try now gRPC. gRPC, as you know, is a two-way communication. So gRPC, what is going to happen? You send a request, you can get a pushback from the server. So that's a different protocol. Here is just sending messages back and forward. And what I'm trying to do is some malicious messages across gRPC. Hello, I'm a cat. This is my first message I sent. Nothing wrong. If there is nothing wrong, what I get is the message sent back to me backwards as a mirror, as you can see that. Now, here, I'm doing the same request. Hello, I'm a cat, but base64 encoded. There is nothing wrong. I'm just doing a base64 on that plain text. But now, here I'm having some fun by trying to get your shadow file in a Linux server and permission denied. Doing the same now, doing a base64 encoding of that attack. Again, permission denied. Here I'm sending the same request, but now I'm sending the header of the request. So now let's look at how this looks in the events. Now I'm looking at gRPC. You can see protobuf being detected, gRPC. And you're able to identify here the attack I was sending. base64 encoded, as you can see, this one was specifically sent into the header of the request. If I go into this one, you can see this one was actually sent into the body of the request. And you can see that I'm able to identify both types of attacks. Well, I hope you enjoyed it. I think this is a good time for us to open it to questions.
We do have a couple questions, but I'm going to answer the one that we get asked all the time. Yes, we did record this session, and yes, we will be making the recording available. We will definitely share those out to you by tomorrow. For those of you who are on the LinkedIn community, I provided a link where if you just click on that and just provide your name and email, we'll be able to send out the link to the recording. We also got a question about, do we have a free trial? And the answer is yes. Rick, if you could bring up the slide for the last one, we've got the links that we can display there. But if you just go to wallarm.com, there is a button right at the top that says free trial. It is one that you can actually enable right away. And if you would like a little bit more of a personal demo with Alex and Rick, we also have a book a demo as well. But we do have a question that came in specifically around how this can be deployed. Is this what are the deployment options, and can it also be in Kubernetes?
Yes, it can be deployed in Kubernetes. We support a Kubernetes ingress controller. So if you already have a Kubernetes ingress controller, we support the latest version of the open source project maintained by the Kubernetes project. And you can deploy it as part of your Kubernetes controller. The other deployment also is a sidecar container, and that's another option where you can deploy Wallarm.
Fantastic. There was another question, is how is this solution compared to API security solutions like Okta API security?
One of the main things here is the deep inspection, as I show, and the elements of the request and how we are in the line of traffic, be able to do all this real-time assessment of the attack in all the elements of request from header URI and the body create these automatic rule sets that requires, in the best case scenario, a zero maintenance from you. API discovery to assess your assets, what actually is being the real usage for your APIs, and what are the shadow APIs, deprecated endpoints. So that's innovations that Wallarm has compared to any other provider. Hope this helps.
Thank you. And one last question I'm seeing is, can you protect against the account takeover attacks that are running against APIs?
Yes, so any attack that be detected as a malicious payload. So think about the analysis of the payload that has as a purpose to be able to do an attack, an account takeover. You are able to protect from there. The other thing also, you have the brute force type of feature I demonstrated could also be used for account takeover that could limit the number of requests you have for that specific use case.
Great. And just doing a quick double check with our LinkedIn community, but I'm not seeing any more questions. If there's any last minute questions, please go ahead and put them in the Q&A. And gentlemen, I think that is a wrap at this point. Again, I want to thank everyone who participated today. And again, thank you for joining us, and look for a link tomorrow to not only the recording and the slides, but also an invite to the next webinar we're going to be having. Thank you again, and we look forward to seeing you on the next webinar. Thank you,
Awesome.
guys.
Thank you.
Really appreciate
Thank you so
it.
much.
Okay.
Bye.
Bye.
Bye, everyone.